This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
Okay, maybe first I'll start with asking one question. How many of you know OpenVINO as a toolkit, as an app, as a tool? Okay, you know, one person. Okay, so my name is Mikołaj, and in the next 20 minutes I'll try to change the proportion of people not knowing and knowing OpenVINO, that all of you will have a basic knowledge about what it is and what its power, and I hope you'll be able to try it yourself later. Okay, first about me. I currently work as a deep learning software engineer at Intel, and OpenVINO is an open source product managed by Intel. At Intel, I do not do anything connected to JavaScript. I work on achieving the best possible performance on Intel GPUs by using the power of software. But apart from my Intel job, I am a researcher and student at Warsaw University of Technology. I organize PyData Warsaw, another interesting meetup in our beautiful city. And as well, I organize conferences like Python Summit. And the last information, maybe that I am C++ and Python developer, but what's more important about that information is that I am not a JavaScript developer. I bet this is not very popular in this place, on this stage, that the speaker doesn't have a knowledge, extended knowledge in JavaScript. But this is our project, which started as an experiment, and I think we did it well, and I learned the basics of JavaScript to make it happen. So what is the agenda for today? First, I'll introduce you to OpenVINO to make more than one person know what I'm talking about. Later, I'll tell you how to use OpenVINO in JavaScript, how to create a desktop application with optimized AI in ElectronJS, and if there's time, I will show you the hide your mess behind app. Now, today it was the change. Now it is not hide your mess behind demo. This is hide your mess behind app. This is like last minute change, but it doesn't matter. Okay, so first of all, I bet many of you know the difference between training and inference. First, when we have data and algorithms, we do training to create a model. A model is, in case of neural networks, it's usually weights. And later, when we have the trained model, we can conduct inference to get results from our input, from our prompt, from our input image, or whatever is the model's purpose. So when we have the model trained, this is just a 50% of the success, because after training the model, we still have to deploy it. We still have to get the results we want. So these three questions are important when running inference, when deploying the model. So first of all, we have to ask ourselves a question: how to achieve the best possible performance out of the available hardware, how to get the most popular use cases and cutting-edge AI running, and how to maintain code across different architectures. And to these questions, the answer is OpenVINO. OpenVINO, most people think that I'm talking about some wine or other alcoholic drink, but Vino is it means visual inference and neural network optimization, so it doesn't have anything in common with wine. And more detail what it is. These are the popular frameworks in which you can have your model trained, and you save your model in one of those formats. These formats are supported by OpenVINO. And the most popular frameworks for training neural networks are probably PyTorch, TensorFlow, and Keras. And you can train the model in those frameworks. Later, you convert the model to OpenVINO to optimize performance, specifically, usually on the Intel hardware. So you run it on hardware. But OpenVINO can work not only on Intel hardware. We support also ARM architectures, and this demo I will show you today, it was even tested on NVIDIA cards. And it works on Windows, Linux, and macOS, so basically most of the computers in the world. So benefits are that you can build and deploy AI applications in simple steps, really simply, just in a few lines of code. And it's optimized, it's faster than the original framework like PyTorch. And you maximize performance across different architectures. So OpenVINO is developed in C++, and this is the native language. So feel free to use it in C++ to visit the code and to see how it is built. But we have other free APIs, C, Python, and what is most important for us today, JavaScript. Probably Python is the most popular because this is the language of AI and machine learning usually. So I'll introduce you to some basic functions in Python, but don't worry, it will take just a minute. So first, we install OpenVINO just from PAP. And later in our project, we need to import OpenVINO. If it's computer vision, it's of course an image, but if it's LLM, then we need some prompt. But here, as an example, let's have image as an input. Later, we define the core, and we compile a model for the specific architecture. Because in OpenVINO, we have different compiled models for the specific device. And here we have CPU, but it can be GPU, it can be auto. Auto means that OpenVINO chooses itself the best possible performance. And it can be, for example, NPU, which is a new architecture from Intel. We define the output layer because sometimes there are a few outputs, and we get the result by running the inference. So OpenVINO models are in different format than other frameworks. For example, in PyTorch, we have a .pt format. OpenVINO has IR format, which consists of two files. One is XML file, which contains a model architecture. So different layers are defined, different connections between layers, and binary file, which contains all the weights of the neural network. So how to convert your model in one of those formats to IR format? There are two ways. First is in Python API. We just define, of course, import OpenVINO, and later run one command, which means convert model. And later we can save model in the location of our computer. So this is the really simple way in Python how to do it. Just 3 lines of code. Import OpenVINO and those 2 lines. Or the other way is in CLI. If you have OpenVINO in your virtual environment, you can just run this command, OpenVINO converter, so OVC, and the name, a path to your model saved in different format, and it creates an IR format. You can also download IR format from Hugging Face. You just need to install Optimum Intel. This is an extension to regular Optimum, and you can export in OpenVINO format directly from Hugging Face. Okay, so first, so now we can talk about JavaScript, which is why I'm here. You can install OpenVINO by using Node Package Manager. It's a simple and very obvious way. And later you just import OpenVINO, and same as in Python, define core, find available devices on your computer. For example, if there's a GPU, then this function can find it. And later you read model from the path, define the device, like here it's auto, but GPU, CPU, NPU, as I mentioned before, are also possible. Later you compile a model to the device, and when you have a compiled model and some input person prepared, as I mentioned, it can be some image or in case of LLM some tokens. Then we define infer request. This is something. This is not currently in Python. This is in C++. Also, we define infer request. And in JavaScript, we define infer request. And later, we set input tensor, and we run inference by this simple command. And as I mentioned before, we just find the result tensor, and this is our result. Okay, so now, as I promised, OpenVINO and ElectronJS, how it can coexist, how it can cooperate. So first important thing is the project structure. It is designed in architecture which is called model view component, model view controller. Sorry. And first of all, we define the main file, which initiates the application, sets essential parameters, handles every interruption. Later, we define the front end, which is a user interface, so this view component of the model view controller application. Here is some HTML, CSS, renderer.js. On the other hand, in the backend, we have OpenVINO jobs file, which consists all the OpenVINO operations, also pre-processing, post-processing, every backend component, basically. And what is important, this is the only component in which we import OpenVINO. This is quite important, because it doesn't work if we define OpenVINO anywhere else. And preload, which is a bridge between user interface and OpenVINO jobs. So let's say this controller part of model view controller architecture. And of course, Node.js modules with package.json and package lock. So as I mentioned, HTML and CSS is here, OpenVINO is over there, and ElectronJS functions are in those two components here. Okay, now we have some time, so this is a QR code which leads to the code of hide your mess behind demo in our repository. But what I'd like you to see is the live demo. So this is our application. We can choose the video source. Currently, I have only my laptop camera, so there's only one. I can choose the inference device. Currently, I have GPU and CPU. Sometimes it can be also NPU when you have AAPC laptop from Intel. But now I have only CPU and GPU. And we can start the camera. Okay, so far it works. As you can see, it does nothing specific. But we can turn on the inference. And now the background is blurred. This is the main purpose of this device. And as you can see, the inference time is really quick. We can infer 40 frames per second on auto mode. When you switch to GPU, it will be even faster, probably. Yeah, it's a little bit faster, and on CPU it should be the slowest. Sorry? NPU? No, auto mode is the mode that chooses itself. To be honest, I'm not really sure how it handles this, but I know that it combines a little bit of CPU with GPU. There are some algorithms which choose between available devices in this auto mode. I don't have NPU component in this laptop. That's why I don't have NPU. Okay, and as you can see, the inference is quite fast, but I still have a lag here, which is not a result of inference. It is more a result of blurring functions. But these are all this is how the demo works. So it's really simple, and it just shows how quickly we can infer models in OpenVINO in JavaScript, and that we can create a desktop application with OpenVINO. Okay, so how to do it? Wait a second. Okay, this is a recipe for hide your mess behind demo. So first we take a frame from user's webcam. Later we copy the image. We blur the image's copy. We run inference of, this is the model we use to run segmentation. This is TensorFlow Lite front-end IR model from TensorFlow library, but converted to OpenVINO framework. And we obtain a mask. So 1 when we blur, 0 where we do not blur. Later we multiply the pixels in blurred copy to get the blurred image just where we want it, and later we blend and copy blend the copy with the original image to create one picture. So this is quite simple, and we present the results to the user. But there are two things that we need to remember. First, do not use OpenCV. First, we did it, and OpenCV is so slow when it comes to blurring images that we decided to change into Sharp. But as you can see, it is still quite slow. So this is our pain point of the whole project, blurring. And when you run inference, run it in the separate thread. It makes the log less visible. This is not the end. Okay, here we are. So these are the 4 threads that are in this application. First, we have the collecting frames thread, which just takes frames from the webcam and to make them available for us in the code. So we take the webcam frame. Later, in the separate thread, we run inference on this frame, and we get the result mask for blurring. Later, we do not combine this mask with the frame took here because it was quite a long time before. We take a new frame from the first thread, and we blur this image using the mask from before. Later, we get the result image, and we display it to the user. This thing here results that the image that user sees is not delayed by blurring and inference, but only by blurring. So only this process delays the frame and provokes the lag. Inference does not. So we run it in a loop, and this is how it is done. Okay, thank you very much for your attention. I hope you now more of you know what OpenVINO is and what can be done with it, and that you can use it in OpenVINO and in JavaScript and in ElectronJS. Now, my last call to action is that if you have an idea how to make blurring run faster, you can create a pull request with your idea. We will be very happy to merge it because this is our pain point. If you want to know more about what I just said, I published a Medium article with all the information from today's presentation and a little bit more even. And if you want to stay connected, the third QR code is my LinkedIn. So thank you very much and hope you enjoyed it.
Yep, so we have just one mic. Right. Do we have any questions? When you asked about anyone knows what OpenVINO is, I really wanted to make a joke from the seating, like I know how to open Vino.
This is not a very original joke.
Yeah, I know. I'm sorry. I'm trying my best here. Okay. Actual questions. You're the first one, right? Do we have someone with a mic? This was the first one. I'm sorry. Well, yeah, we have time.
So my question is, so you said that you take one picture and you run inference on it, and then you take another picture to apply the mask.
Yeah, that's right.
And is it like every second picture, or you just taking the current picture?
I take the current picture.
Okay, so it can be variable, like depending on the hardware and its performance. There may be more pictures lost in the process, right?
Yeah, that's right.
So, and for the inference, you also take the current picture at the time.
Yeah, that results in that the mask is not perfectly put on the on the image, but on the other hand, it's better to have a fluent movement than fluent mask.
Yeah. Okay. Just wanted to know if it's like strict or it's momentary.
Yeah. If I run it again, I don't know when my mouse is here. Okay. If I run it again, and I start moving very fast, you will notice that my hand is faster than, maybe not my hand because it's out of the mask. But if I try to move really fast, then you can notice that my movement is more fluent than the movement of the blur behind. That's because my movement in this picture is delayed only by blurring part of the process, and the mask is delayed not only by blurring part but also by inference part. So that was our.
Okay, so you're just updating the mask at the moment the inference on the picture is calculated, right?
Yes, that's right.
Okay, thank you.
Hello, my name is Sergey. I have some questions. Please tell me, Intel processors required only at the time of project compilation, or does the project in general not work on AMD processors and video graphic cards? If it only works on Intel, then what's the point of such application if we limiting the user's base this way?
No, it does not work only on Intel. As I mentioned before, it can. Maybe I'll come back to
you mark that, yeah, RM. I remember, but what about AMD?
It works as well. It works on the OpenVINO project is developed by, maybe not developed because it's an open source project. It's managed by Intel, but it can run on different kinds of architecture. For example, when I was developing it, I was using a computer with NVIDIA card, and it was working as well. And I was also testing this application on AMD CPU and AMD GPU, and it works as well. So the project does not, it's not limited only to Intel architecture, to Intel hardware.
Okay, thank you.
I have two parts. My question has two parts. The first one, the demo was focused on image and audio, and video. Well, can we apply OpenVINO to a text-oriented model?
Of course. On the last slide that I just wait a second. It might take a second. The last one. Okay. If you visit this repository, there we have a lot of projects focused not only on image processing, but we have also projects focused on LLMs, on some chatbots, and etc. Most of them are written in Python, so I'm not sure, maybe this is the only JavaScript demo there, but when you combine the knowledge from this demo, how to run the model in JavaScript, and with processing from our demos in Python, then you can very easily create your own demo in JavaScript using OpenVINO. But getting back to your question, no, it is not limited to image processing. You can run all kinds of models in OpenVINO.
So if I take a general text model like Llama, how much optimization from your experience would I get? Like if I download something from Hugging Face, is it worth it to optimize the model, like off-the-shelf model?
I cannot give you the exact data, I mean, in percentage or other statistics, because currently I don't have them. But I remember working on some benchmarking tasks, and sometimes it was even a few times faster in OpenVINO because of all the optimizations. Usually, yes, it's worth it. First of all, it's not a huge workload to convert it to OpenVINO and run it in OpenVINO, but usually the performance improvement is quite significant.
Great, thank you.
I was wondering regarding the benchmarking, if it's kind of built-in function to benchmark, or is it complicated? And the second question was, does OpenVINO has any costs? Because like optimization probably have some costs. Does it have some costs?
Okay. This is how OpenVINO works. First, when you run the first, let's say, inference, the model is being compiled. Compilation means that it chooses between different primitives, different low-level libraries, how to manage all of the operations. It fuses some operations together to make them run faster, and it creates an execution graph. So and it takes some time. So sometimes it can take a few seconds even to compile the model, but later when you have the model compiled, it should be better performance every time you run it. But if you, for example, change the model with every iteration, then yes, every time it needs to be compiled, and it can take some time. But in most of the use cases, this is not a big problem, and this is not the cost.
This is, yes. Round of applause, please.
Warsaw.